Today we're going to continue looking at section 3.2, which is polynomial functions and their graphs. So today we're going to use something called the intermediate value theorem. We're going to understand the relationship between degree and turning points, and we're going to start graphing polynomial functions. So if I want to explain what the intermediate value theorem is, it says let f be a polynomial function with real coefficients. If f of a and f of b have opposite signs, then there is at least one value of c between a and b for which f of c equals 0. Equivalently, the equation f of x equals 0 has at least one real root between a and b. Okay, so they're saying let a and b, if we're plugging numbers into the function, and I get one of those answers to be a positive number, one of those to be a negative number, if that's the case, then to get from a to b, at some point it had to cross the x-axis, which then gives you a 0 because it touches the x-axis at some point. Okay. So let's take a look at an example. So we're going to show that this polynomial function f of x equals 2x to the fourth minus 4x squared plus 1 has a real 0 between -1 and 0. So what we do is we are going to be evaluating. I want to know what is f of -1 and what is f of 0. So I'll start with f of -1. I'm going to plug -1 into all of the x's. So 2 times -1 to the fourth power minus 4 times -1 squared plus 1. Well, when we raise a negative to an even exponent, it's going to turn positive. So it's really then 2 times 1, so 2, minus 4 times 1, which is 4, plus 1. Well, 2 minus 4 is -2. -2 plus 1 is -1. So f of -1 is -1. Now I'm going to evaluate the second number, which is 0. So I'm going to substitute 0 in wherever I see an x in the function. Every term that has a 0 is going to then essentially cancel out because 0 to the fourth power times 2 is 0. 0 squared times -4 is 0. So that just leaves us then with that constant, which is 1. So notice that when we plugged in -1, we got a negative number. When we plugged in 0, we got a positive number. So because f of -1 is negative, and f of 0 is positive, there is a real 0 between -1 and 0. All right, because since one number is negative, one number is positive, it had to cross that x-axis at some point between them, which tells us that we have a 0, or technically an x-intercept. Okay, so that just verified it. All right, let's talk about turning points of polynomial functions. So it says the graph of f of x equals x to the fifth minus 6x cubed plus 8x plus 1. That picture on the right has 4 smooth turning points. Each turning point, the graph changes direction from increasing to decreasing or vice versa. All right, so notice that here's my picture. They're pointing out all 4 spots where you're either increasing to decreasing or decreasing to increasing. And since there are 4 of them, notice that there's a relationship. So if f is a polynomial function of degree n, so in this particular picture, it's degree 5, because that's the biggest exponent, then the graph of f has at most n minus 1 turning points. So notice that there were 4 turning points. That's because 5 minus 1 is 4. That's the relationship that we'll always have with turning points. So you take the degree, subtract 1 from it. That's at most how many turning points we can have in our graph. All right, let's talk about a strategy for graphing polynomial functions. So first and foremost, we're going to use the leading coefficient test to determine the graph's end behavior. So that's the lesson that we learned yesterday. Okay, so remember, leading coefficient test means we're looking at what type of sign is in front of my first term, what is the exponent, is it even or odd, and that's going to tell us the direction on either side of our graph. So we'll figure that out first. Then what I want us to do is find the x-intercepts. So to find the x-intercepts, that means that I want the graph to touch the x-axis, which means that whatever x is, y has to be 0. So that's why we're going to set that function f of x equal to 0, and we'll solve. So remember, we also have practiced that. We're essentially going to have to factor and then solve each factor. So if there is an x-intercept at r such as a result of x minus r raised to the k power in complete factorization of f of x. So remember, once we have everything factored, when we're looking at that exponent, if I see like x minus 2 raised to the second power, that means I have 2 of the same 0. So remember, there's this multiplicity. So once we're factoring and we find all of the different factors, we have to also pay attention to the multiplicity. So remember, if that exponent, in this case k, is even, then the graph is going to touch the x-axis and then turn around. So it touches and turns. But if that exponent k is odd, well, then the graph is going to actually cross through the x-axis. So we have to find those zeros and then determine the multiplicities to know how is it going to be moving throughout my graph. We're also going to want to find the y-intercepts. Okay, so to identify the y-intercept means that it needs to be on the y-axis, so I need my x to be 0. So that's why we're going to substitute 0 in. So that's why it says by computing f of 0. We're also going to find symmetry. So we're going to use symmetry to help us draw the graph. So there's 2 different symmetry that we're looking for. Sometimes there might not be any symmetry at all, but if there is, it's going to be one of these 2 things. We've got the y-axis symmetry, which means we're going to substitute negative x into our function. And by substituting in negative x, if we end up with the exact same original function, that tells us that there's symmetry on that y-axis. If I plug in negative x and I end up getting the opposite of f of x, meaning that every single term is the same, but every sign is different, then we have something called symmetry on the origin. And then we're going to use now that last thing that we just talked about, which is turning points. So we're going to use the fact that the maximum number of turning points of our graph is n minus 1 to double check whether or not we've drawn our picture correctly. Because if my lead number, if my exponent is 4, well, then I can't have any more than 3 spots where they're turning. So if I end up with more than 3 spots that are turning, going from decreasing to increasing or vice versa, I know right away that I made a mistake when I was graphing. All right, so we're going to use all of those things to now start graphing polynomial functions. So we're going to graph f of x equals negative x to the 4th plus 4x squared. So there's 5 different things that we're going to be thinking about along the way in order to graph. So I'm just going to go step by step. I'm going to number all of my steps. So our very first thing, it said we want to figure out the end behavior. So I need to look at that lead coefficient as well as the degree of the polynomial. So when we are looking at that, I see that my lead coefficient is a negative because I'm looking at this term. It's got the biggest exponent. The number in front is negative. Okay, so I have a negative lead coefficient. And notice that my exponent is 4, so that means I have an even degree. Anytime I have an even degree, that tells me that my graph is going to be heading in the same direction on both sides. Because think about, if I go back to just our very basic x squared term, we've been graphing quadratics now for quite a while. Remember, quadratic is a U, they're going in the same direction. Had we had a reflection, remember, then it'd be pointing down, but it's still going in the same direction. That's because it was an even degree. So same thing here. When it's an even degree, notice that if it's a negative lead coefficient, that tells me that I know that I'm going in the same direction. Because it's negative, it's going to be falling. So it falls to the left and the right. Okay, so if I don't have my graph going down in both directions, then we've made a mistake. Okay, the second thing that I need to find my x-intercepts. So remember, that means I'm going to take my f of x function, which is negative x to the fourth plus 4x squared, and I'm going to set that equal to 0 and start solving for x. Remember, because it's degree 4, that means I technically have 4 x-intercepts. So let's figure out what those are. So what I'm going to do is I'm going to, in this case, have to look for a GCF. I see that they both have an x squared term, and because that lead coefficient is a negative, I'm actually going to factor out a negative with it. So I'm going to take out a negative x squared. So then inside parentheses, I'll be left with a positive x squared minus 4. All right, I can't do anything to factor out that, or to do anything with that GCF that we factored, but the x squared minus 4 is something that I can continue to factor because it's a difference of 2 squares. So notice that that really factors into x plus 2 times x minus 2. So now I can set each factor equal to 0. So because my GCF contains a variable, I get to set that negative x squared equal to 0. I also get to set the x plus 2 equal to 0 and the x minus 2 equal to 0. Okay, with the negative x squared equaling 0, I can divide both sides by a negative, and that gives me x squared to equal 0. And then I'm going to take the square root. Now remember, when I take a square root, I normally get 2 answers. But because I'm dealing with 0, that means that I'm going to not have a positive 0 or a negative 0. But I have to realize that this is technically a multiplicity of 2. I've got 2 answers there. Notice that we are subtracting 2 to get the x by itself and then adding the 2 to get the x by itself. So my other answers will be a negative 2 and a positive 2. So I do technically have 4 zeros there because the negative 2 and the positive 2, each of these would be a multiplicity of 1. So notice that all together there are 4 zeros. So remember, anytime I have an even multiplicity, that tells me that I am going to touch and turn. Anytime I have an odd multiplicity, that means that it's going to cross through. So multiplicity of 2 means I'm going to touch and turn. An odd multiplicity means I'm going to cross through. All right, so I can already plot those 3 x-intercepts on my graph. So 0, 0 is that x-intercept, negative 2, 0 is that x-intercept, and positive 2, 0 is that x-intercept. So those are 3 points that are on my graph. Okay, the third thing that we're going to do is we are going to find the y-intercept. So that means I'm going to be substituting in 0 for x. So I want f of 0. So that means we're going to have a negative and then 0 to the 4th power plus 4 times 0 squared. Well, hopefully we notice that everything is going to be disappearing because everything's going to turn to 0. So we get a y-intercept at 0, 0. Which makes sense. We already have an x-intercept at 0, 0. So it makes sense that because that's at the origin, that's what our y-intercept is as well. Our fourth step is to determine symmetry. So remember, symmetry means that I am going to be substituting in a negative x into my function and seeing, do I end up with the exact same function, or do I end up with everything being the opposite, or do I not get either one of those cases? So I'm going to have the negative, but then in parentheses, I want negative x to the fourth power plus, then I want 4 times negative x squared. So the negative is still going to stay negative, but now the negative x in parentheses, because it's being raised to a positive, it's positive, but to an even exponent, that tells me that the negative is going to turn positive. So it will just then be x to the fourth. Plus that 4 is going to stay there, negative x squared, once again, because it's being raised to an even exponent. When I square a negative, it's going to turn positive, so that would then just stay x squared. So notice that my original function is what I actually ended up getting when I substituted in the negative x. So if it spits out the exact same original function, that tells us that we are going to have y-axis symmetry. So that means that we should have the exact same look on the left side of the y-axis as we do on the right side. Okay, and then our fifth step here is I want to determine the number of turning points. Okay, so what I'm going to do is I'm going to determine the fact that 4 is that degree. 4 minus 1 tells me that there are at most 3 turning points. Okay, so because the only points that I really have on my graph are those x-intercepts, because technically the y-intercept is also that, I know that my graph is going to be heading down on either side. So I know that that's how it's going to end. It might be a good idea for us to maybe make a table of values just to come up with maybe 1 or 2 more points so we have a better idea of what this graph is going to look like. So because I know that I have y-axis symmetry, I can really just focus on either the left side of the y-axis or the right side. So let's say I focus on the left side. I kind of just want to know, if I plugged in -1, what am I going to get? Okay, so if I plug in -1 into my function, let's see what we get. So we're going to have a negative, and then we'll have -1 to the fourth power plus 4 times -1 squared. So I keep the negative from the outside, but -1 to the fourth is +1. Plus, then 4 is being multiplied by -1 squared. Well, that's 1, so that'll stay 4. And notice that -1 plus 4 is 3. So that means I have the ordered pair -1, 3 on my graph. And so because it's symmetric, -1, 3, it's also going to be +1, 3, because 1 away on either side of the y should be the same. So this will give me enough information. I'm going to now connect the points. So notice that it's turning, it's going to touch and turn, it's going to turn, and it's going to go down. So it kind of looks like a W. So notice that we've got at most 3 turning points. Okay, there's a turning point. Down here is a turning point. Up here is a turning point. So there's 3 turning points. Okay. Notice that, like we mentioned, we should have the -2 and the +2. It crosses through the zeros there because they had a multiplicity of 1. And then at the 0, 0, at the origin, because it was a multiplicity of 2, notice how it touches and turns. And there's my graph. Let's take a look at this example. We've got f of x equals x to the third times x plus 2 quantity squared times x plus 1. All right, notice that if we follow our steps, first thing I want to do is I want to figure out the end behavior. Now, in this case, everything is already factored for us. In order for us to figure out the degree, I need to add up the exponents. I see a 3, I see a 2, and technically that last factor has an exponent of 1. So to find the degree, I need to add all of those exponents. So 3 plus 2 plus 1, that tells me that we are going to have a even degree, okay? Because 3 plus 2 plus 1 is 6. So we're going to have another even degree. And if I'm looking at the lead coefficient, I see that technically there's a positive 1 in front with the x to the third. So we have a positive lead coefficient. So once again, even degree tells me that I'm going to be heading in the same direction on both the left and the right side. Positive means that we're going to be heading up. So it's going to be rising. So it rises on the left and the right. Okay, so there's my end behavior. I know I need to have both sides going up. So my second step then is I want to figure out the x-intercepts. So that means I'm taking my polynomial and I am setting it equal to 0. The nice thing about this is it's already factored for us. So that means I get to set x cubed equal to 0. I get to set x plus 2 equal to 0. And I get to set x plus 1 equal to 0. Notice that if it's x cubed, I'm taking the cubed root, but the cubed root of 0 is going to stay 0. But notice that because it was degree 3, that means that I have a multiplicity of 3. Because remember, if I have an even degree, which is 6, I should technically have 6 zeros. With the second factor, x plus 2 equals 0, I'm subtracting 2. And so that gives me negative 2. But because it was technically quantity squared, that means that we have a multiplicity of 2. And then in the last factor, x plus 1 equals 0, I have to subtract 1. So that gives me negative 1. It was a degree 1, so that tells me that this is a multiplicity of 1. So remember, as far as the movement goes, anytime I have an odd multiplicity, it's going to cross through. So multiplicity of 3, it's going to cross. Multiplicity of 1, it's going to cross. But then multiplicity of 2 means that we are going to touch and turn. Okay, so I can plot those x-intercepts. So we've got 0, 0. We've got negative 2, 0. And we've got negative 1, 0. So those three are going to be on the x-axis. Okay, the next thing we're going to do is we're going to figure out the y-intercept. So that means I'm going to substitute 0 in to my function. So we're going to have 0 to the third power times 0 plus 2 quantity squared times 0 plus 1. And even though we could find numbers for what we have in parentheses, because it's essentially going to be multiplied by 0 cubed, which is 0, that whole entire product is going to turn to 0, which once again makes sense. 0, 0 is going to be on my graph because it's not only an x-intercept, it's going to be a y-intercept as well. All right, the next thing I'm looking for is symmetry. So that means I want to substitute in negative x and see what I get. All right, so the fact that we're going to have then negative x to the third power, we'll have negative x plus 2 quantity squared, and we'll have negative x plus 1. Well, we've got negative x cubed, which will then give me a negative x cubed. And then when I have this in parentheses, I'm going to keep that there for right now. But think about it. If I start squaring things, that x squared is going to become a positive x squared. And then here, this is still negative x plus 1. So notice that the sign changes for the x cubed. The sign changes for just that last polynomial of x. But then in the middle, if I square that negative x, it's still going to then give me a positive x squared like it would for the original. So 2 of the signs changed. One of the signs essentially is going to stay the same. So because not every sign changed and not every sign stayed the same, this time I actually don't have symmetry. So no symmetry. All right, I know that because we are dealing with a degree of 6, I know that 6 minus 1 tells me that I have at most 5 turning points. All right. And then just because, once again, I only have a couple of x-intercepts on my graph, it might be a good idea to just plot a couple more points to see what the heck is going on. I know that because my end behavior rises on both sides, I know that I'm going to be heading up. I'm going to be heading up. I know that because I'm dealing with 0 being an odd multiplicity and -1 being an odd multiplicity, I know that those are going to cross through. But then I know for my -2 being an even multiplicity, I know that it's going to touch and turn. So it's just a matter of what's happening kind of in between those zeros. So I'm going to substitute in, and I know that they're not the prettiest numbers, but I'm going to substitute in -1.5 to see what's going on in between those two zeros. And I'm going to substitute in -0.5. All right, so then that will just give me a couple extra points to see what the heck's going on. So when I start substituting in, we'll have -1.5 to the third power times -1.5 plus 2 squared times -1.5 plus 1. And this is where you definitely get to use a calculator. When I use my calculator, I get 0.4. So I know that we're dealing with some kind of number. So it's going to be like right here, right before the halfway mark. So I'm going to just fix this. So I know that I'm going to go down. It's going to touch and turn. It's going to then, I'm going to fix that. It's going to touch and turn. It's going to go down. It's going to cross through that -1. So let's figure out what's happening at -0.5. So -0.5 cubed times -0.5 plus 2 quantity squared times -0.5 plus 1. When I plug all of that carefully into my calculator, I get -0.14. So super, super small number. So I'm going to, have something, super, super close to 0. So it's going to then touch and turn. It crosses through that 0, 0, and it heads back up. So once again, because it was an even degree, we knew that it was going to be heading in the same direction, and we know that it's touching and turning just at one of those zeros. It crosses through. In this case, it says at most 5 turning points. Well, here's a turning point. Here's a turning point. Down here is a turning point. So there was only 3 of them in this case, but you could have at most 5. And there's my graph. All right, if I look at this, it says, let's find the zeros and state whether the multiplicity is even or odd. Okay, so to determine if the multiplicity is even or, well, first of all, to find the zeros, we're talking x-intercepts. So it looks like there's 1, 2, 3 x-intercepts. Let's figure out what those are. So the picture is giving us a scale. So remember, this would be my x values right here, and it's going up by a scale of 1. These are my y values. It's going up by a scale of 10. So if I'm going up by 1s on the x, it looks like I'm at -3. So that's going to be an x-intercept. Notice that it looks like we're at +2. And it looks like we're at 2, 3, 4, 5. So 5, 0 as well. All right, so there are 3 x-intercepts. Those are them. When it says to state the multiplicity as even or odd, we're looking at the picture and we're determining, okay, remember, if it touches and turns, then it's going to be an even multiplicity. But if it crosses through, it's going to be odd. And notice that this one on the far left, it's crossing through because it's going from, the bottom of the x-axis up to the top. Notice that the second one is also crossing through, and the third one is crossing through. So they're all crossing through, which means that all of these are going to be an odd multiplicity. Okay, so it says write an equation expressed as the product of factors of a polynomial function. We're going to use the leading coefficient as either 1 or a -1, and we're going to make the degree the smallest as possible. So the fact is, notice that on the left, my graph is heading down. On the right, my graph is heading up. So because they're going in opposite directions, we should have an odd number for our exponent. Okay, we're writing our answers as factors. So because we already know what the x-intercepts are, those are going to be our factors. So the fact that we know that -3 is a 0, that means x plus 3 is going to be a factor. Because remember, I want to set each factor equal to 0 to get my actual 0. So because my answer is -3, it has to be x plus 3 to set equal to 0 to then subtract to get the negative. I want to keep that an odd, so I want to keep it just like degree 1 because it says it wants the smallest degree possible. I know that it's crossing through, so I knew it was an odd. It wasn't like 2 because then it would touch and turn. All right, my next 0 was 2, so that means I want x minus 2 for its factor. Once again, because it's an odd number, I want to keep that degree 1 because that's the smallest exponent possible. We're dealing with then our 5, so I want x minus 5 to then have that turn to a positive 5 if we were to solve. And once again, because it crosses through, I want that 1. So those would be my factors. Now it's a matter of, is my lead coefficient positive or negative? Well, because the left side is going down and the right side is going up, that means that we should have a positive lead coefficient of 1. All right, because the end behavior, when the graph goes and falls to the left and rises to the right, it's because we have an even or a positive lead coefficient. So that would be my answer. And then it says find the y-intercept. Well, hopefully we're okay with my y-intercept being on the y-axis. I need to understand that with the y's, it's a scale going up by 10. So each tick mark is going up by 10s. So it's 10, 20, it looks like 30. So 0, 30 would be that y-intercept. All right, I would suggest that you pause the video and see if you can follow those 5 steps to graph this polynomial function. All right, so notice that we are adding up all the exponents. So it was really a degree 4, so it's another even degree. We have a negative lead coefficient, so it's falling on both the left and the right. I found my x-intercepts. I saw which one was positive or multiplicities that are even versus odd to know whether or not they cross or touch and turn. We found our y-intercept. I saw that I do not have symmetry. And then I know that there's at most 3 turning points. I plugged in a couple of numbers in between my zeros or my x-intercepts so I could kind of see what the heck was going on. And there's my graph. All right, so that's us using the intermediate value theorem, understanding the relationship between degree and turning points, and then starting to graph polynomial functions.